So now let's try it. Let's try to do this sample problem. Okay, applying the relationship between the current, the time, and also the amount of the substance. Okay, so let's read the question. Okay, we have a technician that is plating a faucet. Okay, kepala pipe kan. Okay, with a 0.86 gram of chromium. So this is the first important information. Okay, it want to plate, okay, an object, a faucet, with the chromium. Okay, then the amount or the mass of the chromium that will be plating the faucet is 0.86 gram. Okay, now we start with the substance. We already have the amount of the substance. Okay, and then the electrolytic bath containing aqueous chromium sulfate. So this is actually your electrolyte, aqueous chromium sulfate. And then another information is said that if 12.5 minutes, so this is our time, is allowed to for the plating, what is the current that is needed? So the question want to know what is the current. Current is I. Okay, that is what we want to achieve. Okay, so if we look at back to our diagram here, we have a mass of the substance that is reduced, which is chromium. Okay, so from the mass, we need to calculate its mole. From the number of mole of the chromium, then we need to calculate the number of mole of the electron transferred. And then from the number of mole of electron transferred, we will apply Faraday's constant and we will calculate the charge. And then from the charge, with the time that is given just now is 12.5 minutes, then we will calculate the I, the current. Okay, so to answer this question, okay, you should know the products at your cathode. Okay, it is actually the chromium given in the question. So that this is our electrolyte. So we should know that when we have a Cr2 SO4 3 means that our ions are Cr3 plus and also SO4 2 minus. Okay, so this is what we did in the first part. Okay, from the electrolyte, okay, we have a Cr3 plus and the sulfate. Okay, we don't need to identify or to consider the competition between the chromium and also H2O because the question told us that we want to produce the chromium. We want to plate with the chromium. So obviously, without thinking about which one that have a greater E naught value, we know that chromium is the one that will be reduced at the cathode. Okay, so we just write the equation of a reaction. Cr3 plus react with the 3 electron and then it will form 1 mole of the Cr solid. This is our balanced half equation that is happened at the cathode. Okay, so after we got the equation, and then now is the next step. We need to calculate the number of mole of the chromium. Okay, from 0.86 gram. And then we want to calculate the number of mole of electron. And we want to calculate the charge that is transferred. Okay, so it's either you want to answer this step by step, or the simplest one is to apply the dimensional analysis that you have learned before. Okay, so we want to know what is the charge. Make it as a subject. Okay, equal to the starting unit is the information that we have in the question. We have 0.86 gram of chromium. Okay, then we need to cut the chromium. So how to cut the chromium is by using its molar mass. For every 1 mole of Cr, okay, it is 52 gram of the Cr. Okay, we do 1 mole of Cr means that we have to cut this. So how to cut it? Because we want to go to the mole of electron and then we want to go to the charge. Okay, so to cut mole of the Cr is 1 mole of Cr solid that is produced. It means that 3 mole of the electron will be transferred. Okay, we don't want mole of electron, we want the charge. Tak sampai. So saya sambung kat bawah. So it is actually multiply with another one step. Okay, to cut the mole of electron. Okay, with the charge. So we have to apply Faraday's constant for every 1 mole of electron that is transferred. It is actually have a 96,500 column of the charge. Okay, so since that this is what we want, the charge, so we stop here. There are 3 steps here. So the first step, this step is actually to calculate the number of mole of chromium. Okay, and then we proceed with this step. It is actually to calculate the number of mole of the electron that is transferred. Okay, and then this step is to calculate the charge. It is simple, right? We solve 3 steps in only one step. Okay, so now you press your calculator. Then you will get the charge.
4,787.88.
This is the amount of the charge that is flowing. Okay, so now we want to calculate the time, the current that is needed. Okay, so we know that Q is equal to IT. So we want I to be the subject. Okay, so I is equal to Q over T. Okay, so Q is 4787.88 over with the time is 12.5 multiply with the 60 second. Okay, because the time need to be in second. Okay, so we have to convert it to second. And finally, we will get the current applied. Okay, so the final answer is 6.38 ampere. Okay, so this is from the amount, then we calculate the current.